Hi everybody, happy Thursday. Today we're going to learn how to graph secant and cosecant. And the book has it on page 175, but I don't think they make it very clear. So I'm going to just graph them on graph paper. So if you have a piece of graph paper, if you don't, go to Google graph paper, free graph paper, and you can print out graph paper. And Target's selling graph paper right now. I just bought it. It was on the main aisle when you're walking. It's on the left-hand side. But we're going to just call it 6.5 graphing cosecant x, y equals cosecant x, and y equals secant x. We've graphed sine, cosine, tangent, cotangent. Now we're graphing secant and cosecant. So y equals cosecant x. Do you guys remember what cosecant is the reciprocal of? Sine. So the values, the y values of the sine graph, if you take the reciprocal of them with the same x's, that's the value of the cosecant. So if a value was 1/2, then on the cosecant the value would be 2, etc. But if the value is 1, what's the reciprocal of 1? 1. And what's the reciprocal of -1? -1. So that's where the graph comes into play. You'll see. But the period is still 2 pi, just like it is for sine. So you draw your lines, your y-axis. We're going to do 2 cycles or 2 periods. We're going to go up to 1 and down to -1. That's 2 pi. That's 4 pi. That's going to be 2 cycles or 2 periods. Sine, does it start up at 1 or at the origin? Starts at the origin. So it goes up and down and down and up. Up and down and down and up. Then you make a smooth curve. Someone turned in a quiz on Monday. So if you didn't turn in a quiz on Monday, you should. But someone turned one in that looks zigzaggy. Sine and cosine are very smooth curves. So then we're doing reciprocals. So what's the reciprocal of 0? Undefined. So x equals 0 is a vertical asymptote. X equals 0 is a vertical asymptote. The next asymptote is at pi, because there's another 0. So you write x equals pi, and see the distance between them is pi. That's half of the period. The period is 2 pi, half of the period, because half of the curve is separated by asymptotes. The next one's at 2 pi. X equals 2 pi. You don't have to label every asymptote, but at least label a couple of them. And then this is the way you do it. This is at pi over 2, 1. The reciprocal of 1 is 1, so this point is on the graph. And then it's going to go like this, up towards the asymptotes. Because if there was a 1/2, it would go up to 2. If there was a 1/5, it would go up to 5. So it's going to go up away from the sine graph. And that's what cosecant looks like. It's kind of cool. They're U's. I call them U's. So we have to graph the 4 U's of the 2 periods. So this is pi over 2, 1. Right here is 3 pi over 2, -1. And you only need to graph a couple points. You don't have to do 5 points like before. The domain is x such that x is not equal to, and it's where the asymptotes are, because that's what values x can't be. And it's all the pi's. So it's pi k, where k is an element of z, the integers. And then it's y such that y is greater than or equal to 1, because it's all the values above 1 and all the values below -1. The book writes it differently, but I like it like this. So I think it's more simple. So domain and range. So that was cosecant. Let's do y equals secant x. Secant is the reciprocal of what? Cosine. So the period is 2 pi. It's almost the same. Hopefully you know the difference between sine and cosine by now. 1, -1. Now these can change because we could do 2 secant x and then you'd have to go up to 2 and down to -2 and make changes like that. So that will be coming in the future. 1, 2, 3, 4, 2 pi. 1, 2, 3, 4, 4 pi. Now, does cosine start at the origin or up? Up. So here, 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 here are critical points. Whoops. It's here, it's not there. I'll ignore it when I'm graphing it. So we go curved, smooth curve. There it is, y equals cosine x. And then where's the asymptote? Here's the first 0. The asymptotes are where x equals 0. So pi over 2 is the first asymptote. The next one is at 3 pi over 2. That's the next asymptote. And the distance between the asymptotes is pi, half the period. And you don't have to label all the asymptotes, just some of them, but you have to draw all of them within the 2 periods. And then this is 0, 1. So 0, 1 is on the graph, but then goes up towards the asymptote, and this goes down towards the asymptotes. And this is at pi -1. And this is it going up for the u's, 2 pi 1. And then these go down, and this one's just half of a u. The range is the same. Y such that y is greater than or equal to 1, or y is less than or equal to -1. And the domain is x such that x is not equal to, the first asymptote is pi over 2. First asymptote to the right of the 0. Right of the y-axis, plus distance between asymptotes, which is pi. It's the period, half the period. Pi k. K is the element of the integers. So we're getting into some complicated stuff. What I want you to do for your homework, number 94, graph y equals cosecant x again, y equals secant x, y equals 2 secant x, so you have to go up to 2 and down to -2, and y equals 1/2 cosecant x. So the amplitude is 1/2 on that one. Give the domain and range, label asymptotes and draw all of them. Label a couple of the asymptotes and label a few points. And that'll be due Friday at 10 a.m. So just plan to have it done by then so we can go over it possibly. You don't have to turn it in like my other classes, but we should keep you on a schedule. So try to have it done and ask me questions. Please ask me questions. Thank you.